Okay, time is 12:30, so let's begin here. So the date number 1 quiz is due now. If for some reason you were unable to complete it, come talk to me after class. Today we will continue with our little introduction to SAS, and maybe we'll get into the data summary and analysis section. Also, just a reminder, you really need to get SAS by the end of the week. I hope to post the first assignment by the end of the week as well. So if you have SAS, and you're going to be able to start the first assignment. Once I have the first assignment completed in terms of written, I will upload it to the website, and I will post a message on the listserv saying, hey, assignment number 1's out there, why don't you go get it, and we'll talk about it in our next class. Are there any questions before we begin here? Okay, so let's go ahead. We left off on page 2 of the notes. Let's go ahead and actually open up SAS here. So I'm just going to come down here and find where SAS is located on my computer. And you simply want the SAS 9.4. That's the most current version. SAS 9.3 will work well in this course too. SAS 9.4 English there, and I open it up. Okay. Now, one of the first things that you see there is you see this little window that says change notice. I know it's kind of small there, but it says change notice. And what that basically is saying that there's been a little bit of changes with SAS version 9.4 versus some of the previous versions. Actually, this change took place in SAS 9.3, but the little message is still popping up. I'll explain what that is later on in the future if you want. You can just click on don't show this dialog box again or check it and close. Okay, so we have a number of windows that appear once you open up SAS. By default, your cursor will be in the Enhanced Editor window. So if I start typing here, you can see which window I'm in. This is where you can type computer programs to run SAS. So statisticians write programs to do statistical analysis, to use statistical software. Generally speaking, we don't use, let's say, point-and-click methods to get the corresponding calculations done. So, for example, you won't see a statistician come up here to the, let's say, the top of the screen, and let's say, suppose there's a little word here that says analysis. Click on analysis, and a drop-down menu pops up and says maybe t-test. I'll click on t-test. Another little window pops up that says pulled t-test or non-pulled t-test. You won't see statisticians do that. Why? Why do we write computer programs instead? The reason is, well, there's a few reasons. First of all, is reproducibility of what you're doing. Typically, it's going to be a lot easier to know exactly how some calculations were done if you have the exact program that did those calculations versus try to remember, did I click there or did I click there? A second reason is very often since we are statisticians, our analyses that we're doing is a lot more complex than what simply can be captured in a menu-based, window-based system. And so because of that, and this is like beyond doing like a t-test or beyond fitting a regular old regression model, but because of our analyses are more complex, that's why we use programs to do our stuff. The Enhanced Editor is where we type our programs. If I wanted to open up a previously written program in this Enhanced Editor, as you might expect, I could go up here to File, Open Program, and then find it on my computer. My favorite way to open up a program is to find the program in a corresponding folder on my computer. In particular, there's one, I know it's kind of small, it says gpa.sas. Again, all SAS programs, as I mentioned last time, have a .sas extension. By default, in Windows at least, you do not see the extension of a file. I always turn that on whenever I'm in like a file explorer so that I can see it. The main thing that you will always see is you'll see this little, let's say, running person right there. That means it's a SAS program. So what I like to do is I simply just drag it over to the Enhanced Editor, and the program will appear in a new Enhanced Editor window. That's how I like to open up programs. Now we'll talk about this program in detail shortly, but one of the things you immediately will notice is that things are color-coded. In terms of the code is color-coded to its purpose. It's called syntax highlight. You often see this in many different programming editors, not just in SAS, but with using other software or other languages. So that's nice. It helps you read what's going on. And that's why this is called the enhanced editor, because you have the coloring there. Also, you'll notice on the left-hand side here, we have a little minus sign. Does anyone know what that might mean?
Shrinks it down.
Yeah, it's called folding. So you can fold your code. So notice that this is, and you'll see this shortly, this is actually a group of code there that will always stay together. So imagine, let's say if that was even a lot bigger. That could take up a lot of your screen. So to help organize stuff nicely, if you want to, you can click on the minus sign and the code is folded up. Okay, if I click on now the plus sign, it opens. Okay, just some very small aspects of using this enhanced editor. Now if I want to run this particular program, and we will look at it, how to run it, we will run it later, but I just want to mention right now, because we're talking about the program, is if you come up here to the little running person symbol, remember how we just saw that like 1 minute ago? Well, if I click on that, that will actually run my program and do all the calculations that this particular program is supposed to do. Now once I run my program, information is going to be put in two main locations inside of SAS. The first location is what's called your log window. And I cannot make the font any bigger than what it is there. At least I can't, for some reason, I can't find a particular option to do it. And this is my log window. And what the log window basically tells me is it's going to actually reprint the code as it's running. It will tell me if there are any error messages. Like maybe I didn't get my code right. Or maybe if I'm fitting a particular statistical model, suppose it didn't fit. I have what's often referred to as non-convergence. Messages like that will be printed there. So the first thing that you typically do after you run a SAS program is you go to your log window and check. Did everything work out? Okay, good. Now let's look at the output that's generated by the program, meaning the actual calculations themselves, the numbers and all that stuff. Go look at that. And where is that located? It's located in what's called, there's a small typo in the notes. This is the bottom page 3. It's called the results viewer. I don't know why I put results explorer there. So all the actual calculation, let's say if you were to estimate a regression model, to know what that regression model is, that information is printed in the results viewer. Plots also will be printed in the results viewer too. Since I haven't run my program yet, you'll notice in SAS, you do not see any kind of window anywhere that says results viewer. When we do run the program, you'll see this window pop up. One thing that you do see here is a window called output. You might be thinking, well, wait a second. If I'm getting computer output from running my program, shouldn't it be there? Well, it used to go there. Remember that little window that popped up right when we opened up SAS? That's what that was talking about. Some changes have occurred since SAS version 9.2. SAS version 9.2 and before, all that output that I just talked about went to this window. Now it goes to this results viewer window instead. That's all. We will not really use this output window, hardly at all. There will be a few times where we will. But the results viewer is better. Basically, it can display stuff in a better format. It uses an HTML format to display its as the underlying thing that's displaying the output, where the output window itself is just an ASCII plain text. That's it. So you can actually save the file to your computer, and from the output window, you could save it and open up in like Notepad, for example. It will look exactly the same as it did in the window. Speaking of plain text files, so let me go back to the Enhanced Program Editor. All SAS programs themselves are not in a particular weird file format, even though you see .sas there. Actually, these are plain ASCII text files. So here is Notepad. So if I come over here to my program once again, this GPA.SAS, or SAS, I should say, program. And I just dragged and dropped it into Notepad. You can see there's the exact same program. Okay. Now, on the left side here, you see some other windows. It says Explorer there. And in fact, if I were to click on Results down below, I get to Results, Explorer, Results, Explorer, Results. Oops, there we go. Explorer, Results. Okay, so this Explorer over here allows you to explore, you could say, different data sets that you have available to you in SAS. In particular, if I click on Libraries, SAS stores all the data sets that can be used for statistical analyses in a library, and you'll see a bunch of libraries there. All this is, and this is just SAS's terminology, but all this is are just actual physical locations on your hard drive. That's it. I'll show you, we'll talk more about that shortly. Now if I come back over here and click on Results, this will be more important once we have that results viewer appear. Basically what's going to appear on the left-hand side there are, you can say, hyperlinks to places in your output to find particular information. So like, let's say if you were to estimate a regression model, there will be a hyperlink automatically generated by SAS in this results part right there. And if you click on it, it will take you to that particular spot in the results viewer. You'll see us do that shortly. Now, in terms of some of these little shortcuts or these icons up here, we've already talked about the running person symbol. Notice it says submit. We submit the program, run it. If I come over here, as you might expect, I have the little save icon. When preparing for this lecture today, I was thinking, you know, I wonder, well, let me ask you this. I think you all should know what the answer is, but why is the save icon like that? What is it symbolizing? What? Like a floppy disk, a diskette, yeah. And you know, I'm teaching my 7-year-old son Callum how to use the computer, and I'm waiting for the answer or the question from him. It's like, why is it shaped like that? You know, when you think about it, you know, I bet in 10 years, you know, I'll be teaching this course, and students will be probably might not know. But anyway, so obviously you save the program to your hard drive or wherever you want to locate it. And lastly, of these icons up here that are important, we see this exclamation mark with a circle around it, and notice when I hover over it, it says break. Sometimes when you're running a SAS program and you're watching that log window, you'll see, oh, I have some warning messages. Oh, things are not going right. Uh-oh, I don't want to run this program anymore. So you break it. You stop the program, you click on that button. You might have to click on it more than once to get it to stop. Okay, so that's the basic layout of what SAS looks like when you open it. One other thing I want to mention on page 4, I do have it typed. SAS is not case sensitive. So this language, the SAS programming language that we're using, is not case sensitive. This is going to be different from when we use R, which is case sensitive. Okay. Any questions before we look at you can say the guts of this program right here? Okay. So here's my SAS program, GPA.SAS. the basic motivation behind this program, in terms of statistical motivation, and we're going to be using the corresponding data set a number of times this semester, is I have a particular data set. It's called GPA. And what this consists of are high school GPAs and college GPAs for students. Maybe, students here at UNL. I actually made up the data. As a statistician, I need to say, don't make up your data, but it's useful for teaching purposes. So it's a very small data set. I often use this in many of my classes as a beginning place to talk about stuff. There are 20 observations in this data set. Let me open it up again. There's different versions of the data set. This is the first version that we're going to look at. It's called gpa.txt. It's called TXT because it's a plain ASCII text file. Very common format that we use to store data. There are two variables, high school and college GPA. And as you would normally do, you put at the very first line of the data file the names of the variables. Now below each of the variables, you have then the corresponding actual high school and college GPAs. So for example, the first student in my sample had a high school GPA of 3.04. The second, and a high school GPA of 3.04, college GPA of 3.1. I use an actual space to separate the two values. I did that also with the variable names. So this is what's referred to as a space delimited file. Please be careful about that. Let's say instead I hit the tab key to separate out 3.04 from 3.1. That's now a tab delimited file, even though you don't see something that looks like a tab there. It looks like spaces. But if you tell SAS, hey, I have a space delimited file when it actually is tab delimited, or vice versa, SAS will probably come back with you and say, I can't read them, I can't get the data. There's something wrong. So SAS can be very picky on the data format. So again, 20 observations. And where would this kind of data may be useful? Let's say that you are working for the admissions office here at UNL, and you want to use this data set to come up with a regression model to predict college GPA based upon high school GPA, so that you could apply this model then to new applicants to the university. And you can say, given what they have for a high school GPA, how do I think they're going to do in college? And depending upon what your regression model says, you could use that information to decide, well, should we admit this student or not? So that's the basic motive, the statistical motivation, the data motivation behind this example. What we're concerned about with right now is how can I get this data set into SAS so that I can use the data? So I need to read it in. Okay. So first, before we actually even read it in our program, we need to start off SAS with some stuff that I typically use in all my programs. You should as well. That basically gets SAS ready to go. This first line here has some really weird syntax to it. You'll never see this syntax probably in your career in any other part of SAS, so I'm not going to get into the exact details why the syntax is in this form. Rather, I'm going to tell you what it does. The DM stands for Display Manager. So immediately you might think, okay, this line of code is going to control how certain things are displayed. Kind of does. Notice you see log, clear. Remember how we had a log window? Simply, it's going to clear out the log window. So anything that was in there before, it's going to clear it out. It's a good way to start it when you run a program, because you don't want to look at some stuff that was maybe there before in another running of the program. ODS results clear. What that does, it clears that results viewer window. Now, why is it ODS though? ODS stands for Output Delivery System. We'll look a lot into ODS in the next subsection of our notes. So output delivery system. And clear. Notice the line ends with a semicolon. And in fact, if you look at all my lines here in my SAS program, I end them with semicolons. Any complete statement in SAS, typically it's just going to be on one line, but sometimes it might go down to 2 lines or even 3 lines. Any complete statement in SAS has to end with a semicolon. This is a characteristic of many programming languages that are, let's say, older. Newer languages typically don't have that restriction where you have to actually tell the computer, it's the end of the line. But in SAS you do. Now the next line here, options, okay? You might be thinking, okay, this controls, again, some of the ways that I'm using SAS. It does. The options that I set here, I primarily set them because it makes my lecture notes look nice. Whether or not you use these options, it's up to you. So options, line size equals 64, meaning I only want 64 characters on one line. That's it, of my output, that is. So 64 characters per line of output. The reason why I do that with my lecture notes is because I don't want my output to extend over the size of the page when I put it into my lecture set of notes. No number, no date. I don't want page numbers in my output. I don't want dates in my output. And when I have used SAS in the past, I typically want that. But again, this is just for my lecture notes. It makes them look nicer. If I don't have the date always displayed, I don't have the page number always displayed in my results viewer, and so that's why I removed it. Next, you're going to see a number of different lines that begin with asterisks. Whenever a line begins with an asterisk, that tells SAS this is a comment. Comments are used throughout programming languages to help put into regular, let's say, English, what maybe some syntax actually means. And so it's a good standard practice that whenever you have a SAS program, at the top of the SAS program you have some comments such as, okay, put the name of the author, when did you write it, what's the purpose. Because, maybe 6 months, a year, or even many years down the line, you want to come back to this program, you're wondering, what does it do? Okay, it does a data analysis example using the GPA data set that I do. I've worked with a number of people who use SAS a lot that are actually, that's essentially just their job to do SAS programming. And the format that they typically use for comments is what I'm using here. So that's why I'm structuring it in this format. Now, you might be wondering, why do I have some lines have a lot more asterisks on it, and other lines, I always end with an asterisk. That's just style. And that style comes from, and I should maybe set this out of order, comes from when I see what professional SAS programmers use. Professional SAS programmers use. Okay? It's only the asterisk itself that's important, that first one. And then where that semicolon ends the line. So then I come down to some more code here. Since many of you are new to SAS, you don't know what a Title I statement does, I put a comment there to help describe what this does. What does it do? Well, Title I means the first line of every page in the results viewer always will have Chris Builder, static 50. It's just a good habit to get into, to help identify, this is your stuff for what class.
For the comments, so a semicolon needs to be at the end of each line, but if you have a bunch of lines of comments, can you just have a semicolon on the last one?
Yeah, so you could just do a sorry, I didn't mean to talk over you. You could just have a semicolon at the end of the last one, so You'll notice if I delete that, everything's okay.
Okay.
But SAS, is going to not pay attention to the fact that there's an asterisk there.
Okay. So you could just have one asterisk and one semicolon for like a few lines.
Yes, you could. And there's even other ways to do this. Sometimes when there's a lot of comments, I usually see this whole bunch of asterisks together, but sometimes when there's lots of comments, especially in other parts of the program, people will do this. This is a little shortcut where you have a slash asterisk and then an asterisk slash. That tells SAS, I have a whole bunch of comments there. I don't want to worry about semicolons at all. This is all comments. So that would be another way to do it. I do mention that later in the notes, but it doesn't hurt to mention this now too. Also notice how comments are in green. So look what happens. Look where my cursor is. So you can see where my mouse is. Look where my cursor is. And I'm going to delete that semicolon. Look what happens to my color coding of my syntax. Now Title 1 is actually part of that comment. I mean, we don't want that. But this shows you how SAS then thinks of this as one complete statement now. That it basically starts at the end of this semicolon, and it goes to this semicolon. Then when I put that semicolon back, we get what we want. Any questions? Okay. Now we finally get to reading in the data set. There are a variety of different file formats out there for data. The one I showed you already was the space-delimited plain ASCII text. That's the simplest format, so that's what we're going to start with. We will look at other formats as we go along here. There's going to be two main ways that you can read in data sets in SAS. The first way is to use what's called a data step. Again, this is called a data step. Data steps will be used throughout the semester, because not only can you use a data step to read in a data file into SAS so that you can use that data, it can be used to change the data in some manners, maybe add variables to the data set. It can actually do some statistical calculations, like let's say you want to find the 0.95 quantile from a t-distribution with 5 degrees of freedom. Okay? You can find all that within a data step. The basic structure of a data step is you start off with data, makes sense for a data step, and the data step actually ends with a run. So notice the syntax highlighting there to help you see that. Also remember how I folded the code before. Everything was within that data step. Now data steps, so I told you a little bit what you can do with them. Every time you run a data step, you are creating a new data set. And so you have to give that data set a name. For the lack of a better name, I decided to call this data set Set 1. Set 1 is going to contain that GPA data shortly. I could have called it something else. I could have called it Set 2, Set 10, I could have called it Chris, I could have called it GPA. I could have called it anything that I want. Remember, SAS is not case sensitive. I could have, let's say if I have a data set that, to describe it well, I like to have more than one word with it. So not just set 1. Maybe I want set mine. You have to connect that set with that mine in some way. The way to do it is with an underscore. So if you have multiple words that you want to use to describe a data set name, set underscore mine. You cannot use a period to do that. You cannot use any other symbol to do that. You could simply do this, set mine where you use capital letters, but just realize that since SAS is case sensitive, when you see set mine maybe displayed like in the log, it will actually display it without those capital letters. So I usually use an underscore when I want to use more than one word to describe a data set name. Okay, so let's now read in this data that was stored in a gpa.txt or txt file that we just saw. So again, there is the data set. I want to bring that into SAS. The way to do that is you tell SAS, where is that file located? So use in file. I want to read it in. And I specify the actual physical location on my computer where this file is located. So along directory, at least up here, it's probably listed a little bit differently in the notes. Then notice that in this file, the actual data starts on line 2. So I use an option with that in-file statement. The option is first obs. First obs equal 2. Second line. And then I need to say, then in the next line here of this data step, I need to tell SAS, well, what do I want to call the variables? So I say, what am I bringing in? What's my input? Well, how about we call the first variable HS for high school GPA? Suppose we call the second variable college for college GPA. Notice those are not the same exact names as what you saw in that plain ASCII text file. So let's run this. How do I run all this? Well, one way is if I were just to click on the little running symbol right now, my whole program is going to run. But we haven't talked about the whole program yet, so let's just highlight the portion that I do want to run. And I come up here to the little running symbol, and I run it. Now look what happens to my screen when I do it. It kind of flashes a little bit. That's because the log window came into play. The log window was cleared out of what was there before. It reprinted my code, and then at certain spots it gives me notes. If there was any warning messages, if I had typed something wrong, there would be like an error message that will be printed there. But what this is telling me is this right here. Note, 20 records were read in from the in file, meaning 20 observations were read in. And it says here, something called set1 has 20 observations and 2 variables. So what this is telling me, it's leading me to believe, hey, I think this worked out. Because I knew I had 20 observations before, I had 2 variables. So this is a good sign. I wouldn't just stop there and think, yes, everything has worked great though. Actually take a look at the data that's now inside of SAS, just to make sure it looks correct. This is an important thing to do, because SAS can be picky. It can, you might think, oh, it's going to read it in no problem, but instead it actually had some missing values read in for some reason, because it didn't understand something that was in the file. So, how can I look at the data set that's in SAS? There's a few different ways. First way that we're going to do right now, it's like if I come over here to Explore, go back up. Remember how I told you earlier that all data in SAS are stored in libraries. And all these libraries are just a way to say it's a folder structure. So if I come over here to Libraries, you see something called Work. By default, SAS puts in all the data sets that it creates into something called Work. Now you see set 1. So if I click on it, there's my data. Looks okay, so I think, indeed this data step did work. Are there any questions? Yes?
In the previous page, you had the post-observation command. Is it necessary to get that command?
This right here?
Yeah.
It is in reading the data set like this, because if you actually look at the file itself, the first row was the variable names. So that's why. It's kind of annoying, but you do need to put that. Any other questions? Yes?
Do you always need to put that input?
Yes. You always have to put the input there to say, hey, these are my variable names. We'll look at other ways where you can just pick off the variable names from that data set too, and you'll see that shortly. Now, one of my goals in this class is to actually show you ways to do multiple ways to do maybe the same thing. And, well, you might think, well, that's a waste of time. It's not, because some professors, some people that you work with outside of the university might be used to doing something one way, and others might be used to doing something another way. So what I'm going to do is show you multiple ways, the most common ways of doing some of this. Okay. So this is my data set. Now let's say if I wanted to do some calculations with this data set, maybe I want to make some changes to the variables. In order to do that, you need to make sure the data set's closed. Because otherwise, let me actually show you what happens. So I'm going to open it up. Let's say for some reason I wanted to read in my data set again, for some odd reason. Now remember, as you can see down here for what's called view table, my data set is actually still open there. Now look what happens when I try to read it in. Error. You cannot do anything with it, basically. So be careful. It's a common mistake that students and even myself make sometimes, is that I can't get something to work. Oh, the data set's still open. It's odd, but that's just the nature of it. Okay, so let me go back over to my actual lecture notes. A very small typo on page 7. I show you what the log window looks like after I run it, and I had originally some other things in the log window when I did a little screen capture. It just replaces what you see there with what's actually in the program itself. So the program itself has options, line size equals 64, no date, no number. That's all. It's a minor thing. Okay, now when SAS, so SAS has this set 1, which contains all that GPA data, has that available, and you can actually use it for various statistical analysis now. You can use it. You always have to do that first before you ever use a data set. You have to actually bring it into SAS. And what SAS basically does is it takes that data, puts it into its into the format that it wants to use, and then actually writes it to your hard drive. So it actually physically creates another file on your hard drive called set1. Where is it located? It's located in a location where you have some temporary files stored. So at least on my Windows-based computer, that's where it's actually located. I'm not going to go there right now, but it is there. This is different than maybe other software packages. Other software packages, such as R, will actually, when it reads in the data, will actually store it in the computer's memory. It won't actually write it to the hard drive, typically. Now, when SAS closes, so if I were to close out SAS right now, is that file still going to exist in this temporary location on my hard drive? No. SAS then automatically deletes it. Okay. So anything, go back here. So there's that work library. Basically, it's just a way to point to that location on my hard drive where that file is going. Anything that's in that work library will be automatically deleted upon exiting SAS. There are, and that's fine, because you have this program that can recreate it. Now, there will be times where maybe you have to do a lot of calculations to get the data set in the right format, and there are ways to tell SAS, hey, don't delete it. You'll see that later in the semester. Okay. On page 9, another little typo. I have single quotes there. This should be double quotes. Well, can't highlight for some reason. The single quotes will work. There's one place in SAS where single quotes means something different than double quotes, and I decided to always go with double quotes this semester, but I forgot to update my lecture notes right there. Okay. Let's say, though, that you want to actually display your data set in the results viewer. So essentially, where the output goes. Very simple way to do this is to use what's called a procedure in SAS called proc print. So, two main aspects of SAS in terms of its coding: data steps and procs, standing for procedures. These procedures are going to be used extensively throughout the semester. They will allow you to, for example, estimate a regression model. They will allow you to do a plot. Allow you to do lots of good things. The most simple procedure out there is proc print, which says, okay, take that data set and print it to the results viewer. So this is how it looks. Proc print, and then I have an option. You're going to see that a lot on these proc lines. You have lots of options available to you. The option I'm using here is called data, which stands for, okay, what do I want to print? I want to print what's in set 1. So say data equals set 1, and then when I say run it, it does it. Notice I have a Title II statement. This Title II statement means, okay, on the second line of the results viewer, put high school and college GPA data set to be descriptive. Now this is the first time that we see the results viewer. So this new window popped up, and you can see indeed it's printed there. As I mentioned before, this results viewer basically creates a file that's, I kind of didn't say this part, it is actually located on your hard drive. It's in a temporary folder. You can actually find the temporary folder if for some reason you have a desire to do it. And it creates a file that's an HTML format. Okay. So let's say that you're not for sure how to use proc print exactly. You're not for sure what the syntax is to use it. Well, you need help. How do you find help? There's a few different ways to find help in SAS. First of all, if something doesn't work, do you immediately email me? No. You first try to find help in SAS first to see if you can figure it out yourself. Then, please feel free to post a message to the listener. So if I come up here, this is the little help symbol, and this is going to open up help on my computer. And I can't make this any bigger, so I apologize if it's kind of small. To figure out how to find the help, you have to understand how the SAS software itself is organized. SAS consists of a number, the SAS software consists of a number of different products. One's called base, which controls the basic things that you can do with SAS, like printing data sets, like doing a data set. Then there's something called stat, which, as you might expect, are statistical things that you can do with SAS, like estimate a regression model. Then there's something called SAS graph, which, as you might expect, allows you to do plots. Then there's something called, well, let me do the same order as I'm doing here, ETS, which stands for econometric time series. So if you know what time series is in statistics in terms of you measure data over time, this contains a number of different procs that allow you to do time series. There's something called IML. Anybody know what IML stands for? By chance? That's okay. Interactive matrix language. So I bet in Stat 821 you will use IML some because you're going to look at how you can do some matrix calculations to do, for example, estimate a regression model. So there's a lot of other SAS products, and SAS then organizes its help corresponding to the products. So proc print is located in the base SAS. Also, just an interesting little note. Get back to my lecture notes. So the standard way that people display the names of these products in SAS, let me make this a little bit bigger. So every product in SAS is usually all capital letters, no matter what, except for base. I don't know why, but that's just the style that they typically use. So don't think that I accidentally hit the caps lock key on my computer when I was typing this up. This is just the standard way that they denote the stuff. And so, notice here in the SAS Help, SAS products, okay? And we want to find base, because that's where proc print is located. So I click on base, and then you have a whole bunch of confusing information pop up. It can be daunting sometimes to find what you need to find in SAS, but that's why we're going through this. And you're going to see something called Base SAS Procedures Guide. So I'm going to click on that. And then you see something called Procedures. And then you see a whole bunch of procedures, in particular, proc print. And here's the help, finally, for proc print. So if I come down to the syntax, you can see, oh, this kind of looks like what we were typing, proc print. And we have some options. Remember how I said that data was one particular option? So I click on options, and you see data. So this is the basic way then that you can use the help. Try to figure out, well, what's the correct syntax to do something? How else can you find help for SAS? Well, do a Google search. Okay, very simple. And what will probably happen is that at Google search, the first location it's going to give you, which is the one that we often always click on first, it's going to give you the location of the online version of this manual at the SAS Institute. Okay, this manual will be structured then essentially in the same way. But what I actually clicked on here to open up that help window is actually on your actual hard drive itself. Okay, are there any questions? So in the help, you will notice that there are a number of different statements that you can use with proc print to do stuff. So for example, maybe I for some reason, only wanted to print high school GPAs. How can I do that? I specify I only want a particular variable using the var statement. So I say var HS. And I go ahead and run that. And what do you know? I only have the high school GPA printed. Some conventions that people use for programming in SAS and actually other languages as well. Notice how I indented var when it was inside that proc print and run. The reason being is because this var is what's going corresponding to proc print. And so I can read this a lot better if I indent it rather than do something like this. Now you might be thinking, well, geez, it's just one line. But let's say, sometimes you might have, let's say, 10 lines inside a proc. It's just a lot easier to read. You'll notice also how I did the same thing with the data step. I indented 2 spaces. Again, this is the convention that people use for programming in SAS. You don't. Well, you do have to do that in my class because I'm going to be reading your code a lot, and it's going to make it a lot easier for me to read it. But outside of this class, if you want to, for Walt Stroop's class, if you want to really get him upset and not indent, go right ahead. Just don't tell him I said anything like that. But always try to indent your code like that. It just makes it so much easier to read. So I like to get to a point where I have talked about how to import data sets in other formats. So we're going to go over a little bit here. We'll end up stopping on page 19. Okay. So how? Like I said, there's a lot of different data formats out there. And there's different ways to actually get that data into SAS. Maybe the overall easiest way to get a data set in SAS is to actually type the data set into the enhanced editor itself. So let me actually go back over to SAS. So let's say I want to, again, put the data into a data set in SAS called set1, for the lack of a better name. And so similar to before, I'm going to input HS and college, because that's going to be the names of the two variables. And then rather than using that in-file statement to read it in from my hard drive, instead I want to type the data with different lines in SAS. So I use a command called data lines. And here you can see, it's nicely the syntax color coding, and it's very nice here. You can actually see my data. Again, SAS is picky in how you type it in. Notice you do not have any semicolons at the end of each of the separate observations in there. No semicolons. In fact, you might be thinking, well, you should put probably a semicolon at the end of 2.6, the last observation. If you do that, SAS will say, hey, I don't like it when you do that. Instead, you actually have to put the semicolon in a line all by itself. It's a quirk. I've never found an exact reason why SAS is structured like that. So if I were to run that code, I got my data set back in SAS. Okay. There are some other data formats here that you may run into sometime in your career. I've run into them, and it's been helpful to know how to read it in a certain way. And I will just let you read some of these on your own. So the one at the top of page 16, read that on your own. Do note that there was a little error there. For some reason, when I was typing my lecture notes, I called the @ symbol an ampersand. Don't know why. So the next one, though, I do want to spend some time talking about, and that is, let's say you have some non-numeric variables. So let's say maybe you're reading in the names of the college students with their high school and college GPA. So, perhaps this is what the data looks like. So suppose that this is the data. So I have high school GPA, and then notice I have a comma, college GPA. This is a different data format too, where it's comma delimited instead of space delimited. So there's going to be two different aspects of this example, comma delimited, and also I'm going to have some, you could say, character variables in it. Then I have first name, I can't just highlight one of them, first name and last name of the student. And because I couldn't think of good first and last names, I just decided to call them first one, first two, last two, and so on. So now this is the data set that I want to read into SAS. How can I do that? I'm going to use a data set. I decided to call it set3 this time to differentiate it from another data set that we've already read in. In file, I give the actual physical location of the file. First observations begin on line 2 of that file. And now I need to say, okay, actually this is comma delimited. The default was space delimited before. That's why we never had to use this option called delimiter. This time it's comma delimiter, so I use delimiter equal quote, comma, end quote. Then, like before, yes?
Why are there two semicolons there?
It's gone. I must, when I was going through this before class, I must have accidentally did that. So then I say input again, the first variable name, the second variable name, the third variable name. Now that third variable contains the actual names of the students. Since this is a non-numeric name, or non-numeric value, I should say, you have to tell SAS it's non-numeric. What's the syntax to do that? You have to include a little $sign right after that variable name. It can be like right after it, like the next character space over right after E, or you could put a space, $sign. You could put space, $sign, it doesn't matter. So for example, for the last variable, last name, notice how I put the $sign there right after the name part. If I were to read that in, to the work library, set3, it did not read in correctly. The reason being is because I think I had the file open to begin with. Oh, there it is. Let's try this again. So you need to make sure that the file is closed for what you're reading in. Let's look at the log. Ah, okay, I just don't have it in the right spot. Okay, looks like it worked. Let's check it out. Yes, indeed it did work. Okay. Okay. Then continuing on page 16, this is another little, I guess, format of the data that happens sometime, every once in a while, but rare. I think I've actually found it to be useful maybe once or twice in my career, but it does happen. You can read that on your own. And the last way that we're going to talk about is to use an actual procedure rather than a data step to read in the data. This procedure is called proc import. This is probably overall my favorite way to read in a data file because it's a little bit more forgiving in terms of if you don't get the data format correct, you know, like what we had to specify with a data step. This is a little bit more forgiving. And so this is my favorite way to do it, and I would typically, most of the time, use proc import to do stuff. So the syntax, proc import. Then you have some options. You know, similar to what we saw with the proc print line, we had some options that we could also put on it. Here, the first option is out. Or actually, you can put it in any order you want, I should say. But the first option I typed here was out. This says, okay, where do I want to put it in SAS? I'm going to create a data set called set6. Then, data file. Where on my hard drive is this file located? We give the actual physical location. DBMS. Anyone know what that stands for? Essentially, Database Management System. CSV. Anyone know what that stands for? Yeah, comma separated values. So remember, it was a comma delimited file. And then lastly, we have an option called replace. I mean, if I already have a set6 there, replace it with this new one. Okay? So that's all on that proc import line. Let's actually look at it in SAS instead. Notice how I actually had two lines there, but again, it was one complete statement in SAS, so that's why you don't see the semicolon until the end of that second line. Now, how do I know, again, of all those options that exist? I can find them in the help. Proc import is located in the base product of SAS. Get names equal yes. What that means is the very first row of that data set contains my variable names. So this is how it's a little bit more convenient than using the data step effect. You can pull off the variable names directly from the file. Data row equal 2, meaning, okay, the data starts on row 2. Then when I run it, everything should work out fine. Let's see. Okay. Go to my log window. Looks like it's good. Let's actually take a look at set6. Yes, indeed, it's just good. Okay. So, very last for today. There are some times where you would like to actually export data outside of SAS. And I give you two ways to do it. The easiest way is proc export. Works very similar to proc import. Please try running my code on your own to make sure you understand how it works. Another way is to use a data step. And the reason why I'm showing you the data step way is because sometimes you'll see people use that way as well. the data step. Notice that little syntax typo. I should use double quotes instead of single quotes. This data step here introduces a new concept that we haven't seen before, but we will look at it a lot in the future. And that is, in the data, between data and run there. First of all, well, let's actually look at this first. You see set. What this tells SAS is, I want to create a new data set based upon what I already had in set 1. So based upon what's in set 1, do some stuff for me and put it in a new data set. That new data set, its name would be right there. But kind of as a slick SAS trick, you could say, I decided I didn't want to actually create a data set itself because all I want is the data outside of SAS. And I did underscore null underscore, which prevents SAS from actually creating a data set. So take a look at some of this on your own. If you have questions, let me know. And then what we will start off with next time is the serial data example on page 19, which will integrate a lot of the concepts that we just talked about today, and also introduce some new stuff as well. Are there any questions? Okay, and that's it for today.